Hello everybody, welcome to the October 3rd Friday night star party. This is our Tsukimi Harvest Moon star party. It is a star party where we're going to feature mostly views of the harvest moon in the tradition of the Japanese autumn festival of Tsukimi. And this star party is in memory of Denise Gamble and sponsored by Majorie Wally ED. Thanks Majorie for your support. So we're going to start by putting out on the roof, so you guys can see, we're going to get people up here soon. And I'm just going to put the camera we have for out on the roof there. And let me bring it up and transition. Alright, so that you guys can see that there. Okay. You'll be able to see the people coming up, and that is the moon out there in the background. Okay, welcome everybody. We will have the microphone on so that you can hear what's going on in the dome while we are here tonight. Set on my
It's right here.
Okay.
John, Titan is bigger than Mercury.
I don't know that off the top of my head. You have to ask Google. But it is the second biggest moon in the solar system. It is the only one that has clouds in its atmosphere.
Oh, okay.
The methane is the water cycle happens on, like, not with water, but with methane.
Oh,
Yeah,
okay.
clouds and rains and wolves and rainforest clouds.
Well, I just looked up if it was, if Titan is bigger than Earth, and it
sit down. Please take a seat on the benches. Come on in, take a seat on the benches. There are benches on either side. Just take a seat. There are some over here. Just take a seat on the benches. Don't sweat out too much. I don't have to yell from one end after the other. We do not get that class. No. Everybody, when you come in, please have a nice have a seat on the benches, please. Oh, that's really cool. That's the cake method, right? Oh, no, that's your own piece. Nice. Very cool. Now show me one of those later. Let me get it. Let's go. Okay, everybody, so welcome up here on the roof. Okay, and so this is the Star Party roof. I want to give you guys a chance to get your eyes adjusted to the dark. Because you might not know this, but it takes your eyes about 20 minutes to get adjusted to the dark. And so that's why we use the red lights at our feet up here, because that helps us keep our night vision. So try not to pull out your phone and look at it, because that'll help keep your eyes dark adapted and better for looking through the telescopes. Although I'll say tonight we're looking at the moon, and the moon is really bright to start with, so it might not be as much of a factor tonight. But while your eyes are adjusting, let me point out some things in the sky for you. So if you look straight up, we've got a triangle of stars directly overhead. The brightest one here, which is Vega, second brightest one in the south, which is Altair, one over here, which is Deneb. Those three stars together make what's called the summer triangle, with the three brightest stars, Lyra the harp, Aquaria the eagle, and Cygnus the swan. Deneb is actually a word for that sort of thing. It's a word in Arabic that means tail. It is the tail of the swan. And you might be able to see it tonight. It's a little tough with the moon, but you can see these three stars in the line, maybe, which are this swan's wings. And so from his tail to the center of the wings to his eye, in the middle of the triangle there, that's a big cross. That's the swan. So of course we have the moon over here tonight. That's hard to miss. The moon right now is in a waxing gibbous phase, meaning it's about 3 days before the full moon right now. And the full moon that occurs closest to the equinox in the fall is known as the harvest moon. Okay? Each month usually has a name associated with the full moon, but we call the one closest to the equinox, which can either be in October or September, because the equinox is on September 21st. We call that the harvest moon. And there's also a Japanese tradition in Japan of during the harvest moon of having an autumn festival. And that festival is called Tsukimi. And so tonight we're having a special star party sponsored by one of our donors that we're calling the Tsukimi Harvest Moon Star Party to kind of celebrate the moon and looking at the moon. So the big telescope is going to be on the moon tonight. And also note this, on the very end here is a 6-inch telescope. It's on the moon. And then as you're going back out, there's a very small telescope out there that Janie's going to be at. And that one also is looking at the moon. But it's different perspectives. It's zoomed in different amounts, so you can take in different parts of it. So I suggest you look at each of them and compare. So you might ask then, what does this telescope do? This telescope, yeah, somebody knows what's over here. So over here, this bright star in the southeast isn't a star at all. That is the planet Saturn. Okay? And so if you go home, if you're trying to find that again, the sun goes down over here in the west, right? So you watch the sun go down over here. You turn around, you look east where the sun will come up, and then if you go to your right, it's up in the southeast, and it's literally the brightest thing over there right now. So if you try to aim a small telescope or a pair of binoculars at it, you might notice it has what Galileo says it has ears. Okay? You'll see a little more detail in this telescope, though, maybe a few of the moves. So actually at this point, eyes are probably adjusted to the dark. I want to give you one more pointer on that. Feel welcome to take pictures. But if you do that, please turn off your flash. Right? Okay? You don't want to be the person at Star Party that blinds everybody momentarily. Okay? So make sure you turn off your flash. Right? I'm also going to just introduce people with telescopes. Carrie here. Carrie is right there. She'll go to 12-inch. Kaya, right there, is going to be helping you guys on the 6-inch. And Janie is outside on yourselves. All right. Excuse me, I need to get through to this window. I'll let you up in a second. Give me 1 second here. Okay. Excuse me, guys. I need to make just one adjustment. Okay, that's a view of the moon. Okay, guys, you can start coming up. Let's get a bunch of people up here to start. So why don't you come around the side and please over there by the wall, okay? Wait for a second. Let's get everybody up. Hey, and do you want to stand right here so you're like in the front row? You can make sure you're one of the first people for the telescope there. You can move around. Let's get more people up. I like to keep the moon. The moon. I like to keep the line moving so that we can get a bunch of people up here. You're gonna be. You're doing a great job. I tell you. You must be motivated.
Oh, it's been a long time since I've been here. A long time. She was little when I was here.
Hi. Well, I'm glad
She
we're
doesn't
able to do
remember
this.
it.
Well, let's try to make new memories.
Yeah.
Then. All right.
And neither does her older
You guys
sister.
are nice. Pulling over just a little bit. Okay, I got 3 small ones there. And do you 3 belong with anybody that came up the ladder already? How many of you got together? Just your two adults with you? Okay, I think. Yeah. You 3 come up and you can stand here and we'll get the adults in right there. Okay? That way we keep it moving to start.
You don't want to go back there because you're going to have to go up these
Yeah, here. Let me move that out of your way, okay? Give me a second here. I'll come back around. Hey, why don't you come right over here, right here. Short one's in the front, tall one's in the back. That makes sense? Can you come over here next to him? That's like a front row seat. That's
It doesn't
perfect.
hurt. This doesn't hurt.
And hit you right there, okay? And then let's let your adults get up here. Don't worry, we got it.
She's 55 years old.
Okay. So,
2 more.
you aren't supposed to say how old your parents are, don't
No.
you know that?
Now we all know.
Okay, and could you be the first, excuse me, sir,
Yes.
could you be the first in the next group? I got enough people.
Oh,
Or
his
is
kid's
he
with
with you
us.
guys?
Yeah, his kid's
Oh,
with
he's
us.
with you? Okay, sorry, I thought there were 3 adults. Okay, hey guys, yeah, you're doing it right. You guard the door for me, okay? Perfect? You got it? Okay, I got a nod. We're good.
Yeah.
Okay, so welcome to the 14-inch telescope. Dome, this is the 14-inch telescope, and we're using it to look at the moon tonight. And actually, now that I look at it, I need to adjust the dome a little. You guys don't, the telescope tracks the sky, but the dome doesn't. So lean in a little, actually, because the roof is going to move. Okay, there we go. Yeah, a little bit of a, yeah, so the telescope actually turns and tracks the sky, but the dome doesn't. So every time once in a while, I have to give the dome a little nudge. Okay, so the 14-inch telescope is 14 inches across, gathering light. So there's a big mirror down here that gathers the light, bounces around inside, and comes out here at the eyepiece. So what you're going to do when you come up here is you can put your hand over here or grab me, kids. Try not to grab the telescope, because what do you think is going to happen to the telescope if you grab it?
It'll move.
It moves. It's not a huge deal, but you know, it takes some time, a little bit of time to get it back. You're going to want to come up, cover and close the eye you weren't using, and just look straight in there. And it's so darn bright, I don't think we're going to have trouble figuring out how to look in there tonight. So you're actually tall enough. Why don't I move that out of the way? Why don't you go first? Okay, you got to tell me what you're seeing, though. I'm sorry, I should have said that. First one going has to tell me what they're seeing. What do you see in there? The moon, yeah. What does it look like?
Light. I see a bunch of craters on this side.
And what's a crater?
Basically.
Okay, I was going to say.
Right, so you can see these big round holes in the moon, which are places that asteroids have hit them. The moon doesn't have an atmosphere, so big, little, it doesn't matter how small a piece is, it still smacks into the surface and makes a hole. Yeah. Here, thank you. Here, buddy. Why don't she go there? Okay, I think you're one step up and you're good, right? Can you do that? Okay, no, you want to look straight in there. Can you do it? You see it? Do you see it? I know it's on your. I can see the light on your face. I know you can see it. But could you give me a sign? Were you good? Okay. Okay. Here. You can take taller person. There you go. Okay. So when you look at the moon, you can, as people have a chance to look at the moon, if we could shuffle around and let the people out that want to get out. And I'm also happy to answer people's questions as we go here too. Now, it's just a big conveyor belt. Someday I'd like to have an entry and an exit on this dome, but now we just have one door.
That would be great.
We all gotta have things to,
Yeah.
look forward to. So another thing you might notice about the moon is it has two different colored areas, right? It has areas that are light and areas that are dark. The darker areas actually have fewer craters on them. And that's a clue to what they are. The areas with fewer craters means that there's been less time they've been exposed to be hit by stuff falling from the sky, so they're younger. So what those big open dark areas are is they're lava plains. When the moon was about 1 billion years old, as it was cooling, it cracked open and lava flowed out of the cracks to fill in these large basins. And so it obliterated and kind of repaved the moon there, right?
Lava came out of the moon?
Lava came out of the moon while it was cooling. So it's kind of like when you bake bread in the oven, okay? And you take the bread out of the oven, and as it cools, the crust breaks and cracks, right? Same thing happened to the moon. As it cooled, it had a crust, and then as it cooled, its insides cooled, it shrank, inside shrank, and it cracked open. And that's how the lunar sees those big dark areas.
Your flash off.
No flash on it. Ready?
There you go. Okay. I saw it all over your face, and then
I have a question for you, sir.
Sure, yeah.
How did the moon get there?
So, the moon.
I've heard different theories. So
The lunar,
I
the
heard
big,
it
great
confused us
impactor
with the
hypothesis. Actually, after the Apollo program and all the stuff we learned from the rocks we brought back from the moon, the great impactor hypothesis is our best bet. So, in short, what that means is that when the Earth was really young, something about a third of the. Hey guys, come over and take a look while I'm
Yeah, go
talking.
ahead, boys. Go ahead. Go ahead.
Something about the third of the size of the Earth came along and smacked into the Earth kind of in glancing blow. Now it destroys the object that hit it, melts the surface of the Earth. The center of the object falls into the Earth, and a whole bunch of material. The Earth kind of has a ring for a while, made of rock. But over about 10,000 years, the rock comes together and forms the moon.
Yeah.
wow.
And actually, these things explain what we've learned about the composition of the moon, about how it doesn't have a very dense core, about the way that the Earth's rotation has been affected by the moon. All of that, and the fact that the Earth is the only terrestrial
Back up a
planet with
little
the
bit,
moon. So it would have to be something unique that happened to the Earth that didn't happen to the other three, right?
Right, exactly. It's very,
Yeah, he's got it here. There.
There you go.
very interesting.
You got it? Can you see it? Do you see the craters? Can you imagine how big something would have to be to hit the moon and make those craters? Yeah, because some of those craters are bigger. Some of those craters are bigger than the city of Chicago.
Wow.
Well, they are huge.
Wow, yeah.
The one up near the top that has all the rays coming out of it is called Tycho. And the one that's kind of in the middle of the dark patches, that one, that biggest one, kind of near the bottom of where you're looking, that one's called Copernicus. All the craters on the moon are named after, well, on the near side, they're named after scientists and philosophers from ancient times. The far side of the moon, which we didn't get to see until we sent space probes out there in the 1960s, are all named after scientists from the 20th century.
Now, I did buy him an anchor on the moon.
Yeah,
Okay, well, is he ever going to be able to collect is the question.
Right.
And actually, by international treaty, the moon belongs to everyone.
Right, yes.
It's kind of like Antarctica in that
It
respect.
did say that we don't own it,
Yes.
but he has lunar citizenship, so if we ever do own it, he
All right.
does get to vote.
Okay.
Yeah, right.
But he's like, but as of right now, no.
Have you guys seen it?
All right, cheers,
Come
sir.
out here. You put your hand here and you climb up and you can.
Was that
Oh,
cool,
there you go.
Benji?
You see it?
Yeah.
Did you see it?
I have not seen it yet. We were letting the kiddos kind of, you know. Well, hold on, wait for us, okay, kiddo?
I got a 6-inch one. You said
Well, and so the one on the end of the roof is a 6-inch
Okay.
telescope.
Oh, yeah, that looks-
And you'll be able to see the whole moon at once through that one. It about fills the field of view. So,
Wow.
so here you're zoomed in, so you see about a quarter of the illuminated moon right now. This one, That one you'll see the whole moon, and the 3-inch one outside where you came in, the moon will look just a little bigger than it looks in the sky too.
Isn't that really cool, Benji? Are you gonna be on the moon someday?
Ooh,
You think so?
I like it. Astronaut Benji, I like it.
All right, dudes. Let's give other people turns. There's lots of
Can you let the
people.
grown-ups
Yeah,
in?
there are other telescopes to look through too.
Yeah. there's some
And you
more
can
down
come
there.
back if you want. So
Oh, very good.
yeah.
The grown-ups are gonna take. Yeah, you
Just
guys
wait
can.
here. Wait here till we're done. We're just
yep.
gonna look.
Yeah,
real
give
quick.
your grown-ups just
We're
one
just gonna-
second,
Yeah, we
guys.
want to take a peek.
1 second. Because you want that was neat. Do you guys have any questions?
You guys have any questions about the moon?
No?
Where's the flag at? Is it?
The flag.
Moon made of cheese.
Well,
And the moon made of cheese. No, it's made out of rocks. Just like the rocks on the surface of the earth. And we know that because when people went to the moon in the 1960s, each of those missions going to the moon brought back about 400 or 500 pounds of rocks.
That is so
So we
cool
have
to
a
see
lot
it
of
that
rocks
close.
from the moon that
You
we
can
can
actually
use to
see all
study
the
what
little
it's made of.
dimples.
Yeah. And none of them were made out of cheese. Yeah. Oh, yeah.
Too bad. Be some stinky cheese though, wouldn't it?
The smallest feature you can see on the moon from our atmosphere blurring
That is
the
really
view
crazy.
is about the size of a
You can
football
really see
field.
all the tiny
Wow.
little.
So if you want to see the flag in the Lunar Lander Center, so just go ahead and watch.
Hey, face
There-
this
NASA
way when you go
has
down.
a,
You guys can go ahead.
Like
a
turn around
satellite
and go
around
butt
the-
down.
Look at me, yeah, butt first. There you
Yeah.
go.
wow, that's
Called,
great.
called the Lunar Reconnaissance Orbiter.
Oh yeah.
And if you go to its website, it has photographed the entire moon. They have flagged the Apollo landing sites as you can go and you can scroll around them and see them at 1 meter resolution.
Wow.
And you can see the tracks from the buggy, you can see the lander. I don't know if you can make out the flag at 1 meter resolution, but you can see a lot of the
Oh,
other
yeah.
activity. Yeah. The other things
Okay,
that
go
are
ahead.
behind.
That's neat. You can really
What's your question?
see the creek.
What's your question?
How do we make the rocks?
How do we make rocks? So rocks are basically just like, so heavy atoms are made in stars. And so when a supernova goes off, it makes all kinds of like silicon and iron and nickel. And that's the stuff that makes up rocks. Yeah.
The little minerals make
Yeah.
up rocks.
Did you know that stuff,
It's made out of
the stuff that
stars.
makes your fingernails, that's silicon.
I like that.
And a lot of the rocks here on Earth are made out of the same thing.
Very
Okay.
cool.
Pretty cool stuff.
Thank you so much.
Oh, you're welcome.
That was
Thank you.
very good.
Yes, thank you.
I want a telescope that big. Can
You can buy it off the shelf, but I suggest that you buy an enclosure because rolling it out to the yard every day is a chore.
Oh yeah. But well, 6 inches is enough work probably for me. But yeah, that's really
6
cool.
inches, a little more portable, yeah. Thanks for waiting, guys. Come on up. Come on up. Move on up. You're next. Come around over here on this side. Please stand right there. You'll be first in line. You guys will be first. Go over there. You'll be first. We'll get the kids first. That sounds good. And why don't you guys step up a little so the adults can shift behind you and you still get a front row seat. Sound good? You weren't an adult. Stand a little closer. He thinks he's bigger. That's fine.
What's wrong?
Okay, let's get some more people in here. I want to
So I
keep
think they were
this
saying, like,
moving.
you guys be in
This
front of us.
moving. Don't worry.
Yeah.
Yeah, we got room there.
That's what he said. He said to
There's
go.
room in front of you guys
He said
too.
you guys
I'm
go in
not
the front.
gonna.
Here, so that
Okay.
we can.
And let's see. Could you step forward?
Thank you. I missed it. That's what he told me.
Okay. Are you with him? No. Is she? Okay. Can you be the first in the next one? Okay. Okay. So, welcome to the 14-inch telescope dome. So this is the 14-inch telescope, which refers to the size of the opening on the front and the size of the mirror, excuse me, in the back. So the light comes in the front, hits a big mirror back here, is focused and bounces around to come out an eyepiece right here. Actually, you can kind of see the moon on my hand here, on the eyepiece, right? Okay. So we're looking at the moon tonight. You'll want to cover or close the eye you aren't using and look straight into here. I don't think there's anyone. Let me center this up for a second. Let me move it so that you see the whole moon in there. It looks like all you guys are tall enough that you aren't going to need to step up here. But if you need me to adjust the height of the eyepiece at all, I can adjust it up and down a little. Actually, you might need a little bit of a step, right? Okay. Hold on over here instead of grabbing the telescope as you step up. Okay, the rule is though, if you go first, you have to tell us what you're seeing. Can you do that? Can you tell us what you're seeing? What do you see in there? The moon. Yeah, but how do you know it's the moon? What are you seeing on the moon? Does it look just like a big light in the sky? No. What kind of detail do you see? I can see it on your face, actually. But that's enough. I don't have to. You don't have enjoy it. And when you've had your fill, please move on. So you'll notice that the moon is not a big white, smooth thing in the sky. It's got bumps on it. It's got terrain. Could you step over so she can step up? Yeah. Okay. There you go. And so when you look at it, you'll see it as craters. Those big round holes are basically places where rocks have hit the moon and blasted big holes in it. Okay. The moon doesn't have an atmosphere, so when rocks fall out, yeah, when you guys have had a chance, move over so the person behind you can get. There you go. Yeah. Okay. So when the moon doesn't have an atmosphere, so when rocks hit it, they leave big holes in the surface. Oh, you want to step up? There you go. Another thing you can see is that the moon has light and dark patches. The dark patches appear much more smooth with fewer craters in them. We call those the lunar seas. They're actually a younger piece of the surface. They're a spot where, when the moon was younger, it cracked open and lava flowed out into the big basins. So it ended up repaving that part of the moon, starting over, and that's why it has fewer craters, because it's a younger surface that hasn't been hit by stuff for as long. Move over so you can let them down. Yeah, there. Okay. You don't have to leave yet, though. Do you guys have any questions right now? As we're letting other people look through. No questions? All right. Anybody have any?
We want to see the flag.
So the smallest object you're going to be able to see on the moon with an earthbound telescope, because the atmosphere blurs the image, is about the size of a football field. So no telescope is going to be able to show you the flag.
All right, so is the flag still there?
But if you want to see the Apollo landing sites, NASA has a website for their Lunar Reconnaissance Orbiter. That is a satellite that's been orbiting around the moon for over a dozen years, taking pictures of the whole surface. And they have flagged on that site from the pictures the sites for the lunar landings. And you can go there and you can see the tracks from the rover, you can see the stuff they left behind and all that stuff. So I can't show you that tonight, but but you can go and see it on the NASA website. Hey, Carrie, everything okay?
We need your help for a second.
You need okay. Do you want to swap out so
Yeah.
you can just make sure people? Okay. And when you guys are ready to go down and your parents say okay, where do we need help? Which telescope?
14, sorry, 12.
Is there a
speaker back there? Like a microphone? There is a microphone. Yes.
I thought it was just
Like an echo.
big white orb craters.
I thought it was just the echo from the.
Yeah, me too.
The resonance. So is the flag still there? On the moon?
Oh, I actually don't know. We'll have to ask John. I'm not sure.
He said that there was.
No, there's someone else who knows the answer to that question. See. Did they
Does anybody else want to
Yeah,
come
they
around?
did.
Yeah, we're gonna put you guys on ready.
They did. They jackhammered it.
Sure.
What? I'm killing the room. We had a little jackhammer spot. And then jackhammer it. Of course they did that.
They found a little jacket.
They did bring a car.
I personally kind of trust them.
Hydraulics.
Seems added.
The more added it seems less interesting.
It's really bright.
Oh my God! Right.
I was gonna go forward. You think that's possible?
Yeah.
I was gonna do that until I saw
You're athletic.
Is this from the camera right out there?
Yes, that's what you're seeing through the telescope.
Oh, okay,
Yeah.
gotcha. Thank you.
Hey, Carrie, I got it back. So
Okay,
it's
thank
fixed.
you.
That's my fault for setting it up so somebody could keep the leg. We're missing the guy tonight. I'm the last guy. Oh. Pull that Carrie down. Everything good?
Yes, thank you.
Okay, thank you. Okay, follow me up. And just come around over to here, please.
Coming up, buddy.
Right over to there. Okay, we'll get a bunch of people up. Okay, come on up. Why don't you stand right here? Can you see it? Short astronomers in front. Everyone good? Okay, you're right there. That's good. Let's try to. The more people I can get in at a time, the faster this goes. You know, we didn't have much of a line for any of the ones in September. I don't know. Tonight, everybody must like the moon. And that's
Forgot about
fine.
September. That's our first one, I think.
Oh, okay. We usually do them on Friday nights in September and October. Could you take a move over here? Let's just try to get a few more people up and use the space we've got.
How many concrete?
Okay. How many in your group? 2. You guys can fit right here. Why don't you do that? I will let them get up. Okay. So, let her at least get on the ladder before I start talking. Okay. So, and you'll be first in the next group, okay? Okay, so this is the 14-inch telescope. We'll come to the 14-inch telescope dome. So 14 inches refers to the size of the opening on the telescope, which is also the size of the mirror in the back. So the light comes in the front, is collected by a mirror in the back, and then reflected around to come out this eyepiece right here. Okay, when we get to the shorter people, you'll want to step up, and when you step up, try not to grab the telescope, grab the wall, or grab me instead, okay? Sound good? Why don't we get people started to looking at the moon, and I can adjust this up and down. That good for you? Oh, cover or close the eye you aren't using and just look straight in. Okay, so the moon looks really different through a telescope. You notice that it is not this big light in the sky that's flat or shiny. It's actually got terrain on it. It's got mountains. It's got these weird features called craters, which are these big holes. It's got these darker plains that are smoother, and it's got the lighter part is more mountainous. So there's a real diversity of landscape on the moon. So those craters, what they are, those holes, are where rocks have fallen out of the sky and hit the moon. And when they hit the moon, they melt that part of the moon, create like a little water drop. Oh, there we go, water drop storm. And as we've looked, we can shuffle around and let people out if they want to get out, or they can stay and ask questions, whichever they want. So actually, are there any questions about the moon right now? You're doing great. You see it?
See it?
Yeah, wonderful. So actually, there are some craters.
I saw some lights.
Some what?
Yeah, I saw some lights too.
Oh, okay.
I saw some lights.
Oh, yeah, don't watch your ankles. There we go. Questions? Anybody got questions?
No?
So those dark areas are called the lunar seas. You'll notice they have fewer craters on them. The reason for that is they are younger than the rest of the surface of the moon. So what those big dark areas is, they're big lava plains. They're places where as the moon cooled, it cracked open and lava flowed out in large basins. And so it repaved the moon there, and so it started over flat, and that's why it has fewer craters in it. When you see a surface in the solar system that has more craters in it, it means it's older, and the one that has fewer craters in it is younger. Right? It's had less time to collect them. Because on the moon, there's no erosion. There's nothing to erase the craters, except maybe a lava eruption, right? That hasn't happened in billions of years on the moon. But it's not like here on Earth, where the craters get erased by water, by ice, by wind. None of that exists on the moon because it has no atmosphere. So as a result, a crater that was made just after the moon is formed is still there. The only thing that's going to obliterate it is another crater forming over top of it.
Do you have any questions?
Question?
No, it's not made out of green cheese. Like
It is not. Hey, somebody else asked me about that. Yeah, so actually, one of the ways we know that is that, during the Apollo missions, with the Apollo moon landings, each one of those missions brought back between 400 and 600 pounds of rocks and samples. So we have lots of rock from different places on the moon that we've studied to try to figure out what it's made of. That's actually led to our best theories about how the moon might have formed.
Thank you so much. It was
Oh, you're
most
welcome.
enjoyable. I
Oh,
love it.
thank you. Thank you. I
Even more
appreciate
so when I put my glasses on. I could actually see what you were
Well,
talking
and I'll
about.
say if you have trouble, if anything's blurry, let us know because we
Yeah.
can
Oh,
refocus
no,
it for
we were,
people.
I was good on those. This is
Good.
great.
Excellent. Excellent. You guys waited, so take your, get your fill.
Thank you so much.
Oh, you're welcome. You're welcome. Thank you for coming out. Thank you for being patient.
It's Doc Martin, right?
Yes,
Okay.
yes,
I
I
think
do.
my sister's in your class, Courtney.
Courtney.
Yeah.
Okay. Okay.
She says hi.
Yes, you bear a resemblance. She was in my
Yeah.
physics class. Yes, yes. And your name is?
I'm Jaden.
Okay, Jaden. I know you as something other than Courtney's sister. Jaden.
Yeah.
Nice to meet you, Jaden.
Every time I call her and ask what she's doing, it's physics. So she's having a good time.
Well, I'll tell you, part of learning physics is practicing physics.
Yeah,
Yes.
yeah. No, she'll explain the concepts to me just as like a way to learn
Well,
it,
no, that's right.
process
Because you
it,
explain
like,
it to somebody
yeah.
else, you know it that much better yourself.
Yeah.
Exactly.
Yeah.
Perfect.
Well, nice to meet you.
It was nice to meet you, Jaden. Yes.
Thank you.
Okay, next group. Thank you for your patience. Go around over to there. We'll let everybody up. Just lead the way. I'll tell you guys what you're looking at in a second. You got it.
They wear a pro.
And
You are a pro.
You want to stand here in the front row so that you can be one of the first people? Okay, step out so that the adults can get behind you, okay?
Right
And
here.
you can be in the front row. Move over, move away from the ladder.
We're on
So,
deck. I don't know how many. Looks like you hold
come
more
on.
people.
Yeah.
How many are?
Between 10 and 15, but I don't have a set number. Come on, I got half of it is empty right now. Come on up.
For 4, 5?
4 or 5, yes. 5, 1, 2, 3, 4, 5. We're good. And then if I got one more, we'll just go with that otherwise. Thank you for, I should have asked how many, yes. See, I think 5 of you can
We'll
stand
squeeze you in here. Come on up.
Yeah.
Come on, come on, come on. Keep
We
the
have
line
4
moving.
more in
I know,
the-
yep.
Okay.
Yep, I've cleared that through.
Gotcha.
Oh, and hey, one of them is half size, so that'll
Yeah.
work just fine.
3.5.
Okay. And actually, you stand up here.
All right,
You
you're
get there in the
front row.
front. Yeah, because you're the shorter astronomers get the front row. Okay. Okay, you guys will be the first in the next group, okay? Okay, thank you. So welcome to the 14-inch telescope dome. This is the 14-inch telescope. Could I sweep by you for 1 second? Okay, so the 14-inch telescope is 14 inches in the front, and there's a mirror in the back that's 14 inches in diameter. Okay, so the light comes in the front, collected by the mirror, it bounces around in there and comes out the eyepiece right here. So tonight when we come to the telescope, you want to cover or close the eye you aren't using and just look straight in there. And you can see it on my eye, right?
Yeah.
Okay, yeah. You can see it right away. When the shorter ones come up, I've got a little stare and I'll help you up to take a look, okay? Okay. Why don't we start taking a look? Well, you guys don't want to hear me talk. You want to take a look. So go ahead. You're standing right there. You start. Yeah. So you'll notice that the moon is not a beautiful, featureless white light in the sky. Like when Galileo first looked at the moon and other people looked at the moon, they noticed it has a landscape. It has mountains. It has plains. It has these things called craters on them. Now, on the Earth, we would think craters are associated with volcanism. But on the moon, they're made by objects falling out of the sky and hitting the moon and making that hole. Okay? They aren't associated with volcanoes at all on the moon. And the moon has no air or water on it. And so that means that as craters form, they're never destroyed. Yeah, there you go. Look straight in there. Can you look straight in? You got it? Can you see it? There, yes, good. You might notice two different types of terrain on the moon. The darker terrain are called the lunar seas, and they have fewer craters in them. The lighter terrain are called the lunar highlands, and it's more jumbled and mountainous. And the reason why the lunar seas are dark and fewer craters is because they're younger. They were formed when the moon, as it was cooling after it first formed, it cracked open and lava flowed out into these basins and repaved the moon. And so those parts of the moon started over with 0 craters, which is why they have fewer craters now. And that dark color is because it's dark basaltic rock from volcanism. Let me move that so you don't knock your ankles against it. Are there any questions right now? After people have had a look, we can shuffle around, you can get out, but I'm happy to answer questions if people have them too.
What is the surface of the moon made out of? I mean, is it typically...
Cheese.
It's made out of exactly the same stuff that the surface of the Earth is made out of. And that's actually part of one of the clues to its origin. The reason why, how we know this is that each Apollo mission that went to the moon brought back about 400 to 600 pounds of rock samples. And so we have lots of rock from different places on the moon that tell us that the chemical composition is very much like the chemical composition of the Earth's crust. It points to a common origin of the two bodies.
Is it actually white-ish?
So it's more gray,
Yeah.
right? It's more like rock, but it looks bright to us because, well, the sky is dark, right? You're comparing it to a dark sky, it looks bright in the sky. But also think about how it looks in the daytime sky, right? It looks grayer then, right?
Mm-hmm.
And so it has to do with the illumination and that it's the only bright thing up there right now.
Is
If we can
Tycho-
move around so people can take a look.
Is Tycho visible on this?
Tycho, yes. So Tycho, I show you on this picture. So this, the picture out there is actually.
Oh, there it is.
And the Sea of Tranquility. I don't know what's going on.
So the picture out there is actually a live feed off this telescope right now. Tycho is the big crater down here on the bottom, okay, which you might have been able to see in there on the top because it's flipped in there, okay? And the Sea of Tranquility is this one right here. So if you're ever looking at the moon, the Sea of Tranquility is about at 3 o'clock. It's right above these two other things that stick down like legs. And the Apollo 11 landing occurred about right there at 7 o'clock on the Sea of Tranquility.
Taurus Littrow?
I'll tell you if you want to know. I know Apollo 11. The other ones, if you watch the slideshow inside, we got a slide that comes up that shows where all the other landing sites are.
Pull a stool towards you, honey.
Let's get out.
People, yeah, make a hole for the people that want to get out. Oh, there we go. Sorry.
You're okay.
How deep are the depressions
The craters?
and craters and how
Hundreds
high are
of
the
feet
mountains?
deep.
Hundreds?
Oh yes, because
Keep going
those
up?
craters you're seeing on there, they are much larger than cities on Earth. I mean, you got to remember, if we took the moon and put it in front of the United States, it would take like 2 United States from one side of the moon to the other. That gives you an idea of scale.
Now, I thought that they found water on the moon.
Right. So there are if the sun shines on it, it has probably caused the water to sublimate because the sun is hot, right? But there are places on the moon where basically the sun don't shine, and that's because they're in deep craters near the poles where the sun doesn't shine in there. We think those might be places where there are cold traps, where ice actually forms, and then the sun never shines on it, so it might still be there. Also, it's possible there might be some water ice buried under the surface because that would be another way to shield it from heating and melting from the sun. Okay. The reason why we're so interested in finding water on the moon is because if you find the water on the moon, you don't have to take it along with you. It's very expensive and hard to lift things into orbit, right? There's actually a scale. If you go to the Science Center in St. Louis and you walk on the bridge between the Science Center and the planetarium, there's a scale you can stand on that tells you how much it would cost to put you in orbit. Okay? Yeah, but also think about taking along all your food, all your water, everything. Anything we don't have to take along saves us resources, right? So that's why we want to find it on the moon. Yeah. Yeah.
Awesome. Thank you. All right.
You're welcome.
Thank you, sir.
You're welcome, yeah. Did you guys get a look or?
Yes.
Okay. Yeah. Any questions?
What's your name?
My name is John Martin. I am the professor of astronomy and physics here at UIS.
Awesome. Thank you,
Thank
Dr.
you.
Martin.
You're welcome.
That's awesome.
Glad it was worth the wait in line, right?
Absolutely.
We got a little bit of a line tonight. That's different, but that's okay. You guys are all in good spirits about this. It's awesome.
Okay.
And show everybody on the Zoom what the line is like out there right now. You can see the moon in the sky over the deck. Yeah. We got just a few people here tonight.
Thank you.
Oh, you're welcome.
Two more. Okay.
Come on up. Thanks for watching the door for me. Let's move around right over there. We'll get more people up here. Keep coming, keep coming. Let's move the line. Wake up, everyone. Line's moving.
Do we keep coming? or-
Yep.
Okay.
I've only got 4 people here. I can get at least 10.
Oh my God.
Maybe more. So we got 4 more. Very good. Can you stand up here? That'll get you near the front of the line. That sound good? Okay. And I want to make sure you weren't like stuck behind all the adults and not able to see. All right. Fill in the space too, people, because I want to. The more people I get up, the more I can keep moving in the line here.
I think your
How-
next group is.
How many do you have in your group? 4? Okay, you'll be the next group. Okay. Okay,
You'll get
thank
yours
you. Yes.
faster.
Yeah. Okay. So this is the 14-inch telescope. That refers to the size of the opening on the front and the size of the mirror on the back. So the light comes in the front of the telescope, hits the mirror, is gathered, bounces around, and comes out here at the eyepiece. Okay. So tonight, to look at the moon, we're looking at the moon. We're going to cover or close the eye we aren't using and just look straight into the eyepiece. Okay. And when we get the shorter person up here, I've got a step for you. Okay? Otherwise, I can swivel this up and down a little if anybody needs it to get it to the right height. Okay, so why don't we go ahead? Come on, take a look. So when you look at the moon, you'll notice that it is not this featureless white ball in the sky. Just like when Galileo and others first looked at the moon with the first telescopes, they realized the moon has terrain, it has mountains, it has plains, it has these things called craters on them. Now on the Earth, craters might be associated with volcanism, but on the moon, there's no volcanism. They aren't volcanoes. What they are is they're big holes where rocks have fallen out of the sky and hit the moon, okay? Some of those craters are gigantic. I want to remind you that the moon is several thousand miles across from one side to the other. So some of those craters are hundreds of miles across, some of the bigger ones, right? Okay? And craters that are formed on the moon, they aren't erased by erosion or other things because the moon doesn't have an atmosphere. It doesn't have water. And so as a result, a crater that's made today sticks around until another crater hits it. You'll notice there are 2 types of terrain on the moon. There is a dark terrain that has fewer craters in it, we call the lunar seas, and there's lighter terrain that looks more jumbled and mountainous. It's called the lunar highlands. Here we go. Let me help her out. So the reason, yeah, good job. You've done this before, right? Try not to put too much weight on that there or it'll move. You see it? Right? Good. Yeah, so the lunar seas have fewer craters on them because they're younger. There are actually places where the moon, when it was young, cracked open and lava flowed out and Reese paved the moon there. So starting over with a whole new set of craters, right? So there are fewer craters on the seas, which are younger pieces of flat area, and more craters in the jumbled highlands, which leads to the big difference you see between them. Anybody have any questions? As we look, we can ask questions or, move around and shuffle out, and we'll let the next group up here once you've all had your fill. Any questions?
So what's the relationship between the moon and the Earth? Is Is it a piece of the Earth that?
Well, so they have a very similar chemical composition. It turns out, and we know this because the Apollo missions have gone to the moon and brought back hundreds of pounds of moon rocks. And so we know from samples all over the moon that the crust of the moon and the crust of the Earth are similar chemical composition, which points to a similar origin, right? Okay. Yeah. So we think actually the moon was formed in a collision between the very young Earth and another body about a third of the size of the Earth that destroys the body hitting the Earth, and then the center of that body falls into the center of the Earth, leaving the moon without a dense core. But then the stuff falling down on the Earth and the stuff that makes the moon in orbit are all the same stuff. It's all jumbled up. It's all the same. And so we end up with similar compositions for what the surfaces of both.
Okay.
What is inside the sphere of moon? Like we are seeing the upper surface. What is inside of that?
So the moon is a geologically dead world. It has not retained enough heat to have lava or a molten center. And we actually know that from the Apollo missions taking along seismographs that they have left on the surface of the moon to kind of record what we call moonquakes, or which, as the waves pass through the moon, you can use the seismographs that are similar to the way we use them on Earth to tell what the inside of the Earth is made later. And we can tell that there are no molten layers inside the moon. And actually, we can tell from the mass of the moon that its density is way lower than the density of the Earth because it lacks a big iron nickel core like the Earth has.
Thank you so
Great.
much.
You're welcome. You're welcome.
So you're married to Sarah, right?
Yes, I'm Sarah Boyning's husband.
Yes.
We know Sarah.
Okay.
Well, actually, tell her you saw Angie.
Angie.
Sarah helped me get my laptop back today.
Okay.
It's a story. But
well, I'll get that story when I get
Yes.
home. If she's not asleep.
And I'm
Thank
the
you,
one
Angie.
that got her into the Boosters Wish Wall. So
Oh, okay.
hopefully
Oh, yes,
that
we've
does
met
not.
already.
Yes, if you saw
Yes,
you red
yes,
and black.
yes, yes.
Yeah.
I'm already. Well, yes.
I
I've
know. I already met with her for that.
I've already been enlisted to move that. Yes.
Oh my
so there we go.
gosh! It's not at your house yet, is
Not
it?
yet. Not
I
yet.
say you don't want that.
You've taken my job, so thank you.
It is like whenever he tried to tell me how heavy it is, I'm like, how heavy can this be? It can't be that heavy.
Well, it's
Holy cow!
It's a big magnetic board, right? So.
Oh my goodness.
Yeah.
It is heavy.
We'll manage. We'll manage.
Oh yeah, no, we managed for years,
we'll
but
keep it.
just that first year was a bit of a shock with it. So.
Well,
Thank you so
thank you
much.
for coming. Just to warn you, I'm moving the dome a little, so don't be startled. Okay, come on up.
Yes. Hello.
Hello.
How are you?
Good, how about you?
All right.
Move around over there. We'll get the 4 of you guys in and then however many else we can fit in here.
I think there's another group of 4.
There's another group of 4. Are they right behind you?
I think so.
Okay.
How much room do you
How many,
have?
how many in your group?
There's a lot of us.
How many? Well,
7?
7. Are some of them smaller?
I have some little guys here.
Yeah, that'll be fine. We'll be able to fit y'all. We'll be able to fit y'all. Especially if some of them are smaller. Okay, smaller astronomers. You guys are going in the front, right here and here. Okay? Okay? Come on up.
All right.
Cool. Yeah, especially if I got the smaller ones. I thought there were 3 of you guys. How many? You with these guys? Come up.
Come on up, Stevie.
Come up or stay down, but don't block the door.
You got it?
It's okay. You can see there's space up here.
Yep.
You're twins.
Okay. And yeah, you two can come in. You're
So
fine.
it's all of us. Nice.
Okay, yes, no problem. Yes, a group of 4 and then a group of 4. Okay, they're perfect. Okay, you'll be the first in the next group, okay? Okay. 14-inch telescope. So the 14-inch telescope refers to the size of the opening on the front. It's 14 inches across, which is also the size of the mirror in the back collecting the light. So the light comes in the front, is collected by a mirror, and bounces around in there to come out here at the eyepiece. So tonight, to look through the eyepiece, we want to cover or close the eye we aren't using and look straight in here. Okay. Now I can turn this a little higher or a little lower, but when the shorter people come up here, I have a step. but we'll move it out of the way for everybody else so you don't hit your ankles on it. Okay? Why don't we start looking, and I can tell you a little about what you're looking at while we do it. So go ahead. Take a look right here. So the moon, you'll notice right away when you look at it, it is not a big pearly ball in the sky. It has terrain on it. It has terrain that's easily recognizable as mountains and plains. But there's also these things called craters. Now, craters on the Earth would normally be associated with volcanic activity, but these are really large, and there are no volcanoes on the moon. And so what those craters are, those big round holes, are places where big rocks have slammed into the moon and created those big holes. Some of those holes, remember the moon is thousands of miles across, so some of those holes are hundreds of miles in diameter and hundreds of meters deep. Okay, they're real. I mean, yeah, they're big. The sense of scale is big. Yeah. Oh, okay. Here, let me move this for you. No, put your hands over here. Try not to grab the telescope. There, your eyes at the right height. You look in there. You see it.
No.
Okay. So you'll notice on the moon there are two types of terrain. There's the darker terrain that has fewer craters, and the lighter colored terrain that is a lot more jumbled and has a lot more craters. The dark terrain is called the lunar seas. And the reason why it has fewer craters is it's younger. One step. Oh no, you're from here. Let's do that. You good?
Tall.
You got it? Okay. So the lunar seas have fewer craters because it's newer. When the moon was younger, as it cooled, it cracked open, and what was left of its molten insides flowed out into these large basins, repaving them and eliminating all the craters that were there, and so they started over and started accumulating craters again. And in the solar system, when you see a surface that has fewer craters on it, that's a younger surface than the one that has more craters, and that's what you're seeing then with the fewer craters in the seas on the moon. As we have a chance to look, if people have questions, I'm happy to answer them, or we can shuffle around and you can leave as you want. Any questions right now?
Oh my gosh. It looks fake.
Is the moon made of cheese?
The moon is made of rock, just like, but we know its chemical composition very similar to the Earth, pointing to a very similar origin. And the way we know this is we actually have samples from the moon. The Apollo missions that went, each of them brought back more than 500 pounds of rock for each mission. Okay, and so we have lots of rocks from different parts of the moon to study, and we know as a result that the rocks on the surface of the Earth and the rocks on the surface of the moon are very similar, meaning they have a similar uncommon origin. Right?
Could you tell the story of the origin of the moon?
So the moon, the best theory we have, the one that explains. Oh, watch out! You got it? Okay. Is that when the Earth was very young, after it just formed, an object about 1/3 the size of the moon, or 1/3 the size of the Earth, came along and hit the Earth. And when it did that, it destroyed the object that hit it. And the center of the object fell into the center of the Earth, but the surface of the Earth remelted, and the pieces from the outside of the object just all mingled together, falling down onto the Earth and making the moon up in orbit, so that the surfaces have the same composition. Yeah. This also explains why the Earth has a moon and the other terrestrial planets don't. The other ones made of rock don't. It would have to be something unique that happened to the Earth, right? And so that's something unique that could have happened to the Earth, but not Venus or Mercury or Mars. Any other questions?
Didn't we find proof that there was water on the moon?
Yes, so it turns out actually there are spots on the moon where we think there are water. That would have to be spots where the sun doesn't shine, because if the sun hits it, water on the moon, since there's no atmosphere, the water would just turn into gas and flit away, be lost, right? Because the moon has no atmosphere. So there are places in shadow on the moon where we think there might be ice trapped that the sun doesn't shine. The best place for that is near the poles, where you have craters that are deep, where the sun doesn't shine down in the craters during the lunar day. And so that's why we're interested in going to the south pole of the moon to explore the insides of some of these craters.
That's pretty cool.
Yeah. Artemis 3 is actually, if they get their act together, two in the spring will be flying people around the moon and back, and the third one will be a landing probably near the South Pole.
Wasn't Artemis 2 supposed to launch like last year?
Artemis 2 was scheduled to be launched this September. Obviously, that didn't happen. They announced about a week ago that there are a series of launch windows in the spring. They're going to try to hit, I believe it's in February, March, and April. And they're hoping to hit the last one, if not one of the earlier ones.
Hopefully.
Yeah, it all depends on having the rocket ready and test it out. Well, we want to let other people up here, so if you got any more questions, I'm happy to have you ask them, but otherwise, good for now?
Well, I have one.
Thank you very much.
Yeah. You have another question? Yeah.
Yeah, what is your favorite moon fact?
I think I share most. I like about how it formed, the great impactor theory. Yeah.
Theia, right?
Yeah.
Isn't it the ancient planet Theia? That's the name of the. In the theory. I think that's the name of the.
That's one of the that could be a name for the impactor, but but it wouldn't have been something that exists now or that we would have been able to in the past, right? Yeah. Well, guys, either move out of the way or let people down. You're blocking the ladder.
Very good, buddy. Good job. Ready?
Well, thank you, everybody.
Thank you. Thank you.
If anybody else wants a last look before you go, come over and do it. People are going down the ladder. You guys can take another look.
Joe, if you hold this for me.
And you can compare it to the other. In the other telescopes, you don't get as close or magnified a view, but you get an idea of more of the whole thing.
I'll give another look.
And if you haven't seen Saturn, make sure you catch Saturn at the telescope in the middle of the deck too.
Does this roof like spin?
Yes, it does. So the telescope tracks the sky as the Earth turns, but every once in a while I have to turn the dome to keep up with where the telescope is going.
You said Saturn was the one in the middle?
Yep, the telescope in the middle of the deck should be looking at Saturn.
That's my favorite planet.
It's mine too. So don't miss it. Don't miss it. Love the rings.
Thank you.
Thank you.
I'm excited.
Yeah, me too.
Can you carry this?
Okay, come on up. Thank you for being patient. Yes. Let's see how the line's doing. Okay, we'll try to get half of it in. Let's go. Move over there. Okay. Yeah, let's move all the way around and we'll let everybody in we can. It looks like we've got a group with smaller people. That's good. We'll move the smaller people up in front. Come on up. Yep. You got room. Hey, how's it going?
Forget about myself. Thank you, sir.
Nice. Glad you made
I
it.
have lost that half a pound. Had a saltine the other day.
And Katie, I think Marjorie can hear us. She is on the stream right now.
Oh,
I think.
that's
She's
fantastic.
And then I think
Katie Williams is here. Come on up to here, please. Why don't you guys get a front row seat, okay? Let the adults be on the wall.
Yeah, I'm not an adult.
You can get a few more people up here to keep this moving.
One more.
Oops, I'm sorry.
Are you a group of one or with the people in front of you? You're with them? Come on up. Come on up. We got it. Okay. So let me shuffle around here. Okay, so welcome to the 14-inch telescope dome. So this is the 14-inch telescope. You'll be first in the next group, okay? Okay. So the light comes in, so 14 inches refers to the size of the opening on the front that gathers the light, and also the size of the diameter of the mirror in the back. So the light comes in the front, so it's a reflecting telescope. The light comes in the front, it's gathered by a big mirror here that then refocuses it, moves it around, and it comes out right here at this eyepiece. So tonight we'll come up and we'll cover or close the eye we aren't using, and we'll look straight into there. I can put this up or down for people with different heights. When we get somebody that's shorter, I got a step and I'll help you out then, okay? Okay? Why don't we start looking and I can tell you guys some things about the moon while you're looking. Go ahead. Take a look. So the moon, when you look at it, you'll notice through a telescope that it's not this like featureless white light in the sky, that it has terrain on it. The first people to look at the moon with telescopes started to realize, hey, that's something up there. That looks like mountains. That looks like plains. That looks like terrain we have on the Earth. Now, one of the things that's really different between the moon and the Earth, though, you'll notice, is it has lots of these circular holes on it. You know, and people at first thought, well, those might be volcanoes because that's kind of like volcanoes here on Earth. But they aren't. They aren't active volcanoes. They're craters, and they're created by rocks falling out of the sky and hitting the moon. And when they hit the moon, they make those big holes. Some of those holes are really big. You got to remember, the moon is several thousand kilometers across. So some of those craters are hundreds of miles across and over a mile deep. They're huge. Yeah. So another thing to look at is you'll notice on the moon there's dark and brighter terrain. The darker terrain you'll notice has fewer craters in it. And the reason for that is it's younger. And it's younger because while the moon was cooling after it first formed, it cracked open and lava flowed out into those basins, forming those big dark basins. Now, when it did that, it wiped out any craters that were there and it started over. And so there are fewer craters in the lunar seas in those dark areas because they're younger than the lighter areas which have never been repaved since the moon was made. The moon, there's no erosion on the moon, no wind, no water, and so the craters are never erased unless you form the lunar seas or another crater hits the moon and wipes it out. Otherwise, a crater or footprint made on the moon just stays there basically for all time. Any questions right now?
Not even solar flares or anything that could reach it?
Well, so there is a bit of sand blasting that occurs because the moon has no atmosphere at all. So even the tiniest bits of dust just slam right into the moon. So it is constantly being sandblasted by all the bits of dust and things that are out there. Hey, come on over. Don't be shy. Don't be shy. Here, and put your hand here to climb up the ladder and look straight in there. You see it? And so when you look at the moon through the other telescopes, you'll get a much more kind of zoomed out view. This is zoomed in about 4 times more magnification than the 6-inch on the end where you can see the whole moon. And I have it kind of focused over on the edge of the moon where its shadow between night and day is, because there you can get a sense of more relief from the craters and whatnot that are there. You got it? Good. Excellent. You probably need 1 step, right? So there.
Yeah.
There you go.
Do you use any like star mapping apps on your phone, and if so, do you recommend any?
The ones I recommend are the free ones. And I use this real clunky free one that probably doesn't even exist anymore. It's just I've had it for called Go Sky app. It's just free. Okay, but you know, and they'll have varying degrees of bells and whistles on them. But I'd say that almost all of them, they use the same basic idea that you hold your phone up, it uses the gyros in it and your GPS to figure out kind of what you're looking at.
Right.
And those are great for identifying bright things. They're great for starting to kind of learn the constellations. And so, yeah, no, that's a great tool.
They point out the stars you can't really see.
Right, or if it's like, what's that bright thing over there? Oh, yeah,
Yeah,
right.
exactly.
And I would recommend if you want to start learning the constellations, that you either start with like the Big Dipper or Orion. Those are Big Dipper in the summer, Orion in the winter are kind of the most brightest collection of stars to start with and work with.
Why don't we like rotate?
Yeah, when people have had a chance to look, why don't we rotate around? If people have questions and want to stay, it's fine. Otherwise, you can work your way down the ladder. Here, the eyepiece is open. Somebody needs to get over here and look.
I'm trying.
Move around, let people through.
I'm not too
There
small.
we go. There we go.
Thank
Any
you.
other questions? Yeah, I'm not holding you guys captive.
Yeah.
You can leave whenever you want.
Is there like a certain area of the moon where the Apollo missions?
Right,
like,
so
usually go?
actually this is and out there, that picture is coming off this small telescope right here. And the Sea of Tranquility is at about, if you're looking at the moon up there, it's a splotch at about 3 o'clock. And you see it's a splotch that has 2 smaller slots, just like legs coming off them. That's the Sea of Tranquility. And at about 7 o'clock on the Sea of Tranquility is where the Apollo 11 moon landing occurred. So when you look up that, it's the black blotch at about 3 o'clock and about 7 o'clock on the clock place of that. Yeah.
Do most of the surface features on the moon have names?
Yes, actually, the ones on the near side of the moon are named after philosophers and scientists going back to the ancient Greeks. And on the far side of the moon, it's named after scientists from the 19th and 20th century. Because we didn't see the far side, because only one side of the moon stays facing towards us, which actually isn't unique for the Earth's moon. Almost every moon in the solar system is tidally locked to its parent planet. But that means there's a far side that we never get to see unless we send space probes to fly by it and look back, right?
So like the Hubble telescope is where we're.
Well, the Hubble
getting
telescope
a
is between the Earth and the Moon, so and we don't point it at the Moon because the Moon is too bright and would actually harm a lot of its instruments, right? But it would only be able to see the near side if we looked at it. Yeah. NASA has actually a satellite in orbit around the Moon called the Lunar Reconnaissance Orbiter that's been there for about 12 or 15 years that has been mapping the surface continuously. And the website is very interesting. You can go to the website, they have flagged so that you can go to pictures of the Apollo landing sites at 1 meter resolution. And they also have discovered, they've been photographing the moon long enough, they've discovered new craters forming from things hitting the moon. Not huge ones, but small craters, appearing where there weren't ones before. Yeah.
Or they look like much smaller craters, almost like bright lights. Like if you're looking at Earth from space, you can kind of see the cities. Like, it would almost seem like a grid of those on there. Is that just smaller craters?
Well, so there are craters of all sizes. Yeah, and actually and so the best place to look here to see kind of the relief is on the edge of the day-night dividing line, the shadow, because you notice over there the sun's hitting things at low angles and you can get a better idea of elevation. But yeah, craters come in all sizes, small, big, little, and actually there are many smaller ones than there are big ones because there's lots more big things to hit the moon out there than there are small things to hit the moon. Yeah. And patterns you might see, well, you're carrying around in your head one of the best pieces of pattern recognition software we have. And so people tend to see patterns and things even when they are optical illusions, right? You've seen those before, right?
Yeah, for sure.
Yeah. Well, thank you guys.
Thank you so much. Appreciate it.
Welcome.
Is there truth to the moon getting closer to the Earth?
So it's not getting closer, it's getting further away.
Okay.
So as the so the moon is the way the Earth is tugged on the moon to make one side of the moon face the Earth. The moon is tugging on the Earth to try to make the Earth face one part of the moon.
Yeah.
And that'll eventually happen, but as that happens, as the moon tugs on the Earth to do that, it actually recedes further away. And it's a matter of a fraction of an inch a year. Yeah, we're able to measure it by bouncing lasers off mirrors that the Apollo astronauts left behind. Yeah.
Well, thank you for all your patience.
Oh, you're welcome. Oh, well, thank you for your patience in line. I'm really glad people are willing to wait. Yeah, please take your fill.
Cece, wait, let her go first. Okay. I didn't know if you'd already gotten one down there. I didn't want to separate you guys.
She ran over here to take another look.
Oh no, I did that too.
All right, Core. Thank you so much.
Awesome. Well, thank you for coming.
Yeah, it's amazing.
I have a question.
Yeah.
How many times, or like yearly, how many times does this moon come around? Like,
So the moon goes around the Earth about once every 28 days. And so the word month actually is derived from the word moon. It's about one revolution around the Earth every month. Now, there aren't an even number of moon orbits per year, which is why on the calendar some months are longer or shorter. But we usually have about one full moon each month as a result.
what about a harvest moon?
The harvest moon is the full moon that occurs on the date closest to the equinox, the autumnal equinox. So the autumnal equinox, when the sun crosses the celestial equator headed south, is on either September 21st or September 22nd. And the full moon on the 6th will be the closest full moon to the equinox, making it the harvest moon. Oh. Sometimes that can happen before the equinox in September, but this year after the equinox in October. Yep.
Thank you.
Yep, you're welcome.
Have a great night.
Yeah. Okay, come on up. I gotta keep the line moving. There we go. I hate to kick people out when they have questions, but we gotta keep moving. Go over there. You guys will get your turn. You guys will get your turn here. Just move on over. Move on over. Come on up.
I'm down, but I didn't think about.
Yeah, we
what I
gotta
had in my
keep the
pocket.
line moving here. I know, I made you wait, so you can make me wait too. That's fine.
It's payback.
Move on over there. Keep on, come on up, come on up. Hey, Matt.
Hey.
One of my regulars. Yeah, you can stand right there. You know, I know you want to be an adult and stand against the wall.
Yes.
Stand up. Look, come on up. We got room. Move over. We got room for people. I wanna make that line a little shorter so people feel like we're going somewhere. Okay, come on up. Are you 2 more? Yeah, 2 more. So you guys move over, and we'll get 2 more in here.
I said I held up.
There we go. Okay. Okay, so as she comes up the ladder, you guys will be first in the next group, okay? So 14-inch telescope here. The 14-inch telescope, 14 inches refers to the size of the opening on the front. You want to get this talk me out? I know you probably do. Okay. So the opening on the front is 14 inches across. There's a mirror that gathers the light for this telescope. It's a reflecting telescope. And the mirror is 14 inches across back here in the back. So the light comes in the front, is focused by that mirror onto another mirror, bounces around in there, and comes out here at the eyepiece. So tonight we're going to cover or close the eye we aren't using, and we're going to look just straight in there to see the moon. And you can see, I can see it because it's on my eye. You can see as I go in there. Let me straighten this out for you guys just a little bit. Okay, I'll give you guys the best view you can. Okay, so why don't we start looking? When we get shorter people up here, I've got a step for the shorter people, but the taller people probably just look straight in. Yeah. So when you look at the moon, you'll realize that it is not this featureless white light in the sky. It has terrain on it. That's one of the things that people first discovered when they started looking at the moon with a telescope. The telescope wasn't invented until about 400 years ago. And when people looked at the moon, they realized it was a different world, but it had similar terrain. It has mountains, it has plains, it has valleys, but it also has these craters on it. And at first they thought these craters might be volcanoes, but there aren't any active volcanoes on the moon. And so what they are is they're holes where rocks have fallen out of the sky and hit the moon and made a hole. Okay, the moon is thousands of miles across, so some of those craters are hundreds of miles across and miles deep. Okay, it's really interesting. As we get a chance to take a look, people move so that the other people can come in. Okay, and you can shuffle around to work your way out, or I'm happy to answer questions as well if you have them. But we'll just keep shuffling around so that everybody can look. Any questions right now?
I believe so.
Oh, well, you weren't required to make that. I'm just saying.
How far away is the moon?
The moon is about, from the center of the Earth, it's about 384,000 kilometers from the center of the Earth. But I looked up, well, it's a little closer than it was when it started the evening. At the start of the evening, when it was near the horizon, it was about 290-something thousand kilometers away. It's probably a little closer right now that it's closer to overhead, but yeah.
Is that the preferred measurement from the center of Earth?
Yeah, so that would be because we would use that to measure the shape and size of its orbit. Because gravity works from using the distance from one center of one object to the center of another.
Huh.
Yeah.
Very cool, thank you.
Yeah, you're welcome.
Going down?
I'll make room for other
Oh,
people.
sorry!
We're like,
Sorry! Here!
look at 2 o'clock, where 2 o'clock is.
Yeah, there's a pretty good one. I
Do you
think I'll
see
go
that
too.
super big crater?
I'll take a picture while I'm doing it though.
Do you see it?
Pointing out Tycho? That's Tycho. That's one of the big craters. It's on the southern part of the moon, but remember it's flipped upside down in the telescope right here. And I can show it to you on the screen over here if you want to when you're done.
Yeah, let's get down and let somebody else get it.
Well, you can circle back and look. So this is oh great. This is upside down. That's the crater, right? And you see, so that's Tycho, and this is flipped upside down in the telescope, so it's on the top of the moon in the telescope over there. What's your question?
You know the moon's first name was Lunar?
Or Luna, if we're going to refer to it in Greek. And do you know what the moon goddess is named in Greek mythology?
What?
Artemis. And that's the name of the moon missions now, right?
Yeah.
Yeah.
Isn't that cool?
Yeah, that is cool.
Now, where do you see a rabbit? I do not see a rabbit.
If you turn it upside down, you see those are the rabbit's ears,
Okay.
his head, his body, and actually he's over here pestiling rice.
He sees it clearly, I don't. But thank you.
But yeah, once you see it though, you can't unsee it though. I'll just tell you that.
Did you say thank you, Matthew?
Thank you.
Oh, you're welcome, Matthew. Good to see you tonight.
Good to see you too.
Any other questions out there?
How does the moon affect the tides?
Okay, so the moon has gravity, and so the moon pulls on the earth just like the earth pulls on the moon. And the water on the earth, though, is able to slosh, right? And so as the moon pulls on the earth, the water will deform and slosh where the land won't as much. And so the moon basically sets it up so that the water starts to slosh back and forth in the ocean basin. It's kind of like if you sat in the bathtub and started to, side to side. And so that's what creates the tides. The moon pulling on the water and causing it to pile up against the continent causes high tide. And then when it pulls it back the other way, away from the continent, that makes low tide.
So is it further away whenever it creates a low tide?
No. It's just the direction that it's pulling, right? You'll notice if you're on the East Coast that high tide occurs kind of when the moon is over in the west, right? Its gravity is pulling the Atlantic Ocean up against the coast, right?
Thank you.
Because the water's pulled toward the moon, right?
Oh, right.
Yeah. So you don't get high tide when the moon is directly overhead. That's
It's just in the west.
Right, because the shape of the ocean floor plays a real big role in it too, because it's how the water piles up against the continent. And that's why tides are higher some places than others, because of the shape of the ocean floor and how it affects it. Yeah.
And we had a question about like how it affects the animals too, because she has like shrimp and they like to change tide pools.
So yeah, because of course if you live in the intertidal zone by the ocean, right? The tides, that's a rhythm set by the monthly motion of the moon, right? The moon takes 28 days to go around the earth. And so life in the intertidal zone becomes, adapted to that rhythm. Yeah.
You had to bring up my shrimp.
No, and that's although shrimp are aquatic creatures that would live in the intertidal zone,
Yeah,
right?
the tide, so they like kind of climb it out and move into other spaces.
Does it affect like non-aquatic animals?
Well, I mean, to some extent too, because the moon is bright, and so nocturnal animals tend to be more active during full moon because they can see better. Just like, and that happens to people too. People get into more trouble during full moon because they can see better. It's brighter outside.
I love going out. I always go. I'm near Centennial Park.
Oh yeah.
I always go whenever there's a full moon.
And I'll say Centennial Park has that nice sledding hill, and at the top, I love to go up there because that gives you a very nice horizon in every direction.
It would be nice if there wasn't like the light pollution, so you could really see everything. But it is a nice spot to go to.
When there have been like comets and stuff that are close to the horizon, I've gone out there because you get a nice flat horizon
The
out there.
one last year, I can't remember what the name was, but I went to see that.
Tushanshan Atlas. Yes, in last October, about a year ago.
Yeah.
That was visible to the naked eye. Yeah.
One more question. Can you show me where the axis is on the moon?
So the rotational axis is roughly like this,
Right there.
north and south. So then I flipped it so that it's not upside down.
Okay.
So this is how you can match it up with what you're seeing in the sky. So the south pole and the north pole of the moon. So the equator would go like that.
So are we seeing it at an angle, or are we at an angle, or is
It
it
is tilted just a little bit because I don't know. Yeah. I can change that by rotating the camera, but
Well, it was really nice learning. Yeah, thank you so much.
Oh, you're
Thank you,
welcome.
guys.
Thank you.
This was an
Thank
awesome
you.
Experience.
Thank you for coming. I'm glad you enjoyed it.
You got it? All right.
Come on up and come around over here. Hello, you look like a repeat customer. I should guess. Come on over. Yeah. You know the drill. We'll get a bunch of people up here. Move on over. Come on up and move on over. Come on up, come on up. I'm gonna keep it moving for people. Move into the spaces away from the ladder and we'll get a bunch of people up here. Maybe I can get the whole line. No, maybe not. Okay. Come on, keep coming, keep coming. I got room for, there's room here. Move away from the ladder, please, so that we have room for more people. You have to step forward, that's fine. And come on up. I got all this room right here, people. Somebody's got to step into there. Don't be shy. We need to move away from the ladder so that people can get up the ladder. Okay, thank you. Thank you. You can be good right there. I have to slide around the side here. Come on up. All right, there we go. You guys can be the first in the next group, okay? Okay, so let me slide around here. You guys can slide back over there. That's fine.
Sorry.
Okay, we got it. Okay, so I could dive underneath, but I might trip over something. So this is the 14-inch telescope, and that refers to the size of the opening on the front of the telescope. It's 14 inches across. This is a reflecting telescope, so it uses a big mirror in the back, and that mirror is 14 inches across. So that mirror, the light comes in the front, is collected by the mirror, refocused up top, and then back down, and comes out right here at this eyepiece. So tonight we're going to want to cover or close the eye we aren't using and just look straight into there. Let's see. I don't have many short people here, so I'm going to keep the ladder out of the way so it doesn't hit anybody's ankles. And if you need this angled up or down a little to comfortably look, please let me know. Well, let's just start looking here. Go ahead. Go ahead. So, something you'll notice looking at the moon is that it is not a big, smooth ball in the sky. It has terrain on it. When the telescope was invented about 400 years ago, we were able to see the moon up close for the first time. And at that time, people noticed the moon isn't different than the Earth. It's similar. It has mountains, it has valleys, it has plains, it has this terrain on it. Now, it doesn't look like there's any water on it, okay? And it's covered in these round holes called craters. But the reason for that is that, well, first people thought the moon was really volcanically active, and that might be volcano craters. But there are no active volcanoes on the moon. And as we have a chance to look, if we could shuffle around just to let more people in and see it. They're actually made by rocks falling out of the sky and smashing into the moon and making those holes. So they're impact craters. And actually, if you're by the, people are trying to get down here, step away from the ladder, please, and let's shuffle around. And people that want to go down and get out, that's fine. But otherwise, I'm happy to answer questions if people have them. Does anybody have any questions right now?
How big is the moon really compared to Earth? Like, could you fit the entire United States wrapped around it, or?
So the moon is about 2 United States from one side to the other. It's several thousand miles across. Okay, the United States is about 3,000 miles across, right? The moon's about 6,000 miles across. So when you look at those craters there, a lot of those big craters, they're hundreds of miles across and several miles deep. They're actually some pretty big holes.
Type of rock is on the moon?
So the composition of the moon is almost exactly the same as the composition of the surface of the Earth, which we know because the Apollo astronauts, when they landed on the moon, each mission brought back between 400 and 600 pounds of lunar rocks. And so we have lots of rock samples from all over the moon, and we know they have a chemical composition almost identical to the rocks on the Earth. And so we can imply from that there's a common origin between the two, right? Yeah.
How many craters are on the moon?
Oh my gosh. Well, you got to start counting is what I got to say. So it turns out that there are fewer big craters and a lot more small ones. So as you look, and that's because for things hitting the moon, there are very few big things that have hit the moon, but there are many, many more thousands or millions or billions of small ones. In fact, the moon is being constantly bombarded even by like pieces of dust hitting it. The moon has no atmosphere, so everything that hits it at full speed and makes a crater. We know, in fact, actually, there's a satellite called Lunar Reconnaissance Orbiter that has been orbiting around the moon, taking pictures of its whole surface for about 15 years. Over that time, we've started to notice, and then going back and photographing pieces again, new craters appearing where there weren't ones before. These aren't huge ones, but so it's constantly picking up new craters as well. Yeah. Yeah, so that's like asking how many grains of sand on the beach, you know? But it's a good question.
Do we know of any planets as close as Earth that has a moon?
Right, so the only the terrestrial planets in our solar system, the ones made of rock, Mercury, Venus, Earth, and Mars, of them, Earth is the only one that has a large moon. And so that actually points toward that the mechanism that created the moon had to be something unique that didn't happen to the other 3 terrestrial planets when they were made.
Why are the impact craters at 90%, like 90 degrees instead of at an acute angle?
So it turns out that no matter what angle you hit a surface at, it's going to make a circular hole. You have to hit it at a very, very oblique angle to make anything more than circular. And actually, so there's a neat story. So Meteor Crater out in Arizona. It's a big crater several miles across that you can go visit. It's south of the Grand Canyon. And when you visit it, they'll tell you about how there was somebody that bought the crater thinking that, okay, I'll be able to find the meteor that made this crater if I dig in the center. And they dug holes all over the center until the story goes that one day the guy noticed, this was the Old West. You notice that if you fire a bullet into mud, that even if you fire it at an angle, you make a circular hole in the mud, and the bullet ends up embedded in the wall. So they started looking around the wall, and they found the meteor that made the crater in the wall of the crater on the side. It had to come in from the side. Yeah. That has to do with the way the energy gets distributed on a big impact like that. It just it's like an explosion that just spreads out from the point of impact.
How far away, or how fast is the moon going away from Earth?
So the moon is moving away from Earth because of a gravitational interaction between the Earth and moon, where the moon is trying to slow down the Earth's rotation, and it does it by little bits by tugging on the Earth. But that means that the moon moves further away as it does that. And we can measure the rate that it's moving away by reflectors left on the lunar lander modules that we reflect laser light off and time the pulses coming there and back. And so we know that the moon is moving away from the Earth at a fraction of an inch a year. Fractions of an inch. So you won't notice it much over your lifetime, but over thousands or millions of years it has an effect. Eventually the moon will be far enough away from the Earth that total solar eclipses will no longer happen because the moon will be far enough away that it won't cover up the sun. Any other questions?
Why is there a dot in the center of some craters?
So some craters have what's called a central peak, because when the impact happens, it melts the surface where it hit. And so it's like taking a splash from dropping something in water and freezing it. And when you drop something in water, you notice it makes a ripple out, but it also causes a reflex in the center. And so that central peak in some of the bigger craters is caused by that effect.
Do we have names for like the major craters?
Absolutely. Almost all the craters on the moon have names, and they're named after philosophers and scientists prior to the 19th century. But don't worry, people from the 19th century and 20th century, they get names on the backside of the moon. Because one side of the moon faces us, and so we're used to that. We've been able to see that since we invented the telescope, right? For 400 years. But until the space age, and we were able to send space probes to the other side of the moon, we couldn't see the side that is always facing away from us. And so that's why the crater names are from people in more recent history on the backside of the moon. Yeah.
Are there any like cool goals or plans to like establish anything on the moon like in the near future?
So the Artemis 2 mission that NASA is launching with 4 people riding up in it. It was supposed to be launched this September, but now they've announced in the past couple weeks that it's going to happen probably this spring. They're going to go and circle around the moon and come back. The first time we'll have sent people out of Earth orbit and around the moon since the Apollo mission, since 1973. Okay? So the mission after that, Artemis 3, the plan is to have it to be a moon landing near the South Pole. And they want to land near the South Pole of the moon because at the South Pole there are craters that are deep enough that the sunlight never hits the bottom of the crater. And so there's possibly water and other stuff frozen in those parts of the crater that never see sunlight at the South Pole. And we're very interested in exploring that, which is why that's the target of exploration for the Artemis missions.
What do you think of the mercury liquid lenses?
Mercury liquid, I've never used a mercury liquid lenses. You might be thinking of a mirror though, because mercury is reflective. Yeah, and we wouldn't use those because mercury is a hazard and you don't want to inhale the vapor.
Do you adjust to the dome yourself, or is it like an automatically?
The dome, the telescope tracks the sky, but I've got to move the dome to keep up with the telescope. Yeah, manually. Yeah. Any other questions? Have we got people staying out there, or are you guys the last group?
There's still a couple people.
Okay, well, if you'd let them come up, that'd be really nice. But I mean, at least a few of guys leave so they can come up. But I do like talking to you, but I want to make sure I get through the line. Thank you for coming out, guys.
Thank you.
Thank you.
Thank you. Thank you.
Yeah, I might be mistaking it for a different type of liquid metal, but there's this dish that they plan on making the dish out of like a liquid metal.
So that would be you would spin the metal, you would spin the liquid metal, and from the spin, then you can make the shape.
Oh, there you go. Okay.
Yeah. That's the idea of it. Because basically the shape you want for a mirror to gather and focus light is to have it be a parabolic shape.
Yep.
And you can
get a parabolic.
And that's why. And one of the ways they make the mirrors, actually, the optical mirrors, the glass ones, is by melting the glass and spinning it while it's molten and letting it cool down while it's spinning. Right? That reduces the amount of grinding they have to do to get the shape.
I never thought of that with the glass. That makes a lot of sense.
Yeah, there are these big, so at the University of Arizona, they used to be under the football stadium, but I'm not sure if it's still in place. They have these huge ovens that are 8 meters across that they can cast 8-meter glass mirrors in.
Really?
Yeah.
Oh my gosh.
What museum did you
That's-
say museum?
That's the University of Arizona Mirror Lab. Yep.
Fantastic presentation.
You're welcome. Thank you for coming. Glad I could satisfy you.
I remember you from last week.
Hey, come on up. It's always good to have repeat customers.
Yeah, instead of my dad, it's my mom this
Oh,
time.
yeah. Well, she must have wanted her turn, right?
Yeah.
Stay right there. We'll help you in a second, right? I know you know what you're doing, but let's get people up here and explain it to them. You want to explain it to them since you've been here before? No, okay, I'll take care of it. Yeah, come on up. We got room. You guys don't have to wait anymore. You can come on up. I think I can get everybody in the line. There we go. Yes. I see Kaya wants to come up, so we'll let Kaya up too.
14-inch in diameter.
Come on up. Come on up. Yeah, I got room. Come on up. There's room. Hey, how you doing? Okay. So this is the 14-inch telescope, and the 14. Actually, I'm just noticing I need to turn the dome just a little bit. Everybody, hold on to your hats for a second. And so the telescope actually tracks the sky, but we need to turn the dome to keep up with where the telescope is pointing. Okay. So this is the 14-inch telescope. That refers to the size of the opening on the front. So light comes in the front, and this is a reflecting telescope, so it uses a big 14-inch mirror in the back to gather the light. It gathers the light, refocusing it up to the top, bounces around in there, and comes out here at the eyepiece. Okay? So tonight when we look at the moon, we're going to want to cover or close the eye we aren't looking with, and just look straight in there. For the shorter part, oh, I know, I can just bend it down for you, right? You tall enough there? Go ahead, have a look. So, the moon. The moon is interesting because it isn't, when you look at it through a telescope, it is not this featureless ball in the sky. You know, 400 years ago, after we invented the telescope, we started looking at the moon and realizing it isn't different from the Earth. It's the same. It has mountains, it has valleys, it has plains. The only difference is it appears not to have any water on it. And there are all these big round holes on it we call craters. At first, people thought, well, those might be volcanoes. They look a little like volcano craters, right? But the moon doesn't have active volcanoes. So what those craters are is they're not volcanic craters, they're impact craters. They're big objects come along, hit the moon, and make those holes. Okay? So they're made by objects falling out of the sky and hitting the moon. And the moon doesn't have an atmosphere. It doesn't have water on it. So there's no way to weather and erase these craters like here on Earth. Like craters made here on Earth a couple 100 million years ago, they're buried under dirt and rock and other things because of erosion. But on the moon, a crater, there's no erosion. And so the only thing that's going to get rid of that big crater is another big crater created on top of it. Okay? And so craters stay on the moon. So when you see some parts of the moon there, you're seeing the whole cratering history since when the moon formed. No, you're fine. You're fine. As we get a chance to take a look, you're welcome to go back down or ask questions, or anybody can ask questions if they got them. Anybody have any questions right now? I can angle that up a little. You okay? Yes. Okay. I'll angle it up a little for the next person. I didn't. Questions? Anybody?
How far away is the moon?
It is about 384,000 kilometers from the center of the Earth. Okay, but we are on the edge of the, and actually, here's a good way to remember that. It turns out that the moon is 30 Earth diameters away from the center of the Earth. So if you set something, like if I said like my head is the diameter of the Earth, and I have a ball there on the floor about the size of my fist, that's about the size of the moon. To do this to scale, I'd have to move this, my fist, 30 head diameters away, about 20 feet. Okay, so that gives you an idea of how far away the moon is and what the relative sizes are.
I have a question.
Yeah.
Can every planet, including Earth, fit through the moon and the Earth?
So yes, there are no. So the biggest planet is Jupiter, and it is 13 Earth diameters from one side to the other. So you could fit 2.5 Jupiters between the Earth and the moon. There you go. Haven't stumped me yet.
I have a question.
Yeah.
So the impacts on the moon, would that have hit the Earth if the moon wasn't in its orbit?
The moon doesn't catch more. It doesn't deflect anything from the Earth. Actually, it's not a very big mass to start with. In fact, it probably hasn't changed the number of things that hit the Earth, really. But on Earth, we have a lot fewer craters because there's constant erosion, right?
Oh, right.
The craters get buried or eroded away, or But you're seeing 4 billion years of cratering history when you look at the moon, whereas on the Earth, they wouldn't last more than 1 million years or so at best, right? Yeah.
Just 1 million years.
Yeah, I also have another.
Well, geological
question.
processes.
Yes.
Yeah.
I also have another question. How much craters are in the moon?
So there are a lot more smaller ones than there are big ones. So that's a really difficult thing to answer. And did you know there are still craters being made on the moon? The Lunar Reconnaissance Orbiter that's in orbit around the moon is taking pictures of it constantly. And as it has photographed and rephotographed the surface, they've noticed tiny craters appearing that weren't there before. So things keep hitting the moon and making more craters. And there are a lot more small ones than big ones, because there's a lot more small stuff hitting the moon than big stuff hitting the moon. It's like asking how many grains of sand are there on the beach in some ways. Yeah.
I have a question.
Yeah.
Why do we call our moon just the moon and not anything else?
Well,
other than...
to be fair, we didn't know there were other moons until the telescope was invented. Okay, so it gets the name the moon or Luna, and it's later that we figure out, okay, that's the body orbiting around the Earth, because prior to that, the moon and the sun and all the planets would have been thought of as the Earth is stationary. Everything moves around it, right? We didn't know the moon was anything special other than it was close enough that it had a bigger size, right? It was about the size of the sun, okay? And we could probably work out that it doesn't shine by its own light, it shines by light reflected by the sun. But, it wasn't called a planet because it didn't look star-like like the planets. It wasn't called the sun because it was different from the sun. And so we called it the moon. But then when we discover things orbiting around other planets, we're like, okay, that thing orbits around another. It's the moon for that planet. Yeah.
I also have one more. What exactly makes the moon so? I know it's the distance, but just how visually does it work whenever the moon gets so close to the horizon and it looks so giant?
That's actually that's an optical illusion. It's because when it gets near the horizon, you have things in the foreground to compare it to. And when your brain does that comparison, you're comparing, you see the moon's bigger than that tree, the moon's bigger than that, and you start to realize and think it's bigger. But when it's way up in the sky, you have nothing to compare it to, right? And so at that point, your brain just runs wild and has no point of comparison.
The other night I was.
Well, if you measure it with your pinky finger, like if you hold out your pinky finger, you see that your pinky finger at arm's length about covers up the moon. And it'll about cover up the moon now, and it'll also about cover up the moon when it's near the horizon. Okay. It doesn't really change size at all.
I have another question. Why is our moon called Luna?
That's just the name they gave it. Well, here's a neat thing to also know. So the word month, yeah, you can come on up. We got people. We shuffle around like here. You have a look. So the moon. If you notice, the word month and the word moon have the same sound to them. That's because they come from the same root. Because it takes the moon 1 month, 28 days to go around the Earth. Now, today our months are not exactly 28 days because there's not an even number of lunar orbits in a year. And so we've made some months longer, some shorter. But it turns out then that we get about 1 full moon every month because of that.
I was curious about something. Is the moon big enough to have like a molten core like the Earth?
No, it is too small, and so it's what we call a geologically dead world because it's lost its internal heat and it has no liquid center. Gotcha. We can also tell that because the Apollo missions took along seismographs that they left on the moon so that they could study moonquakes and how vibrations move through the center of the moon like we do on the Earth.
Yeah.
That's how we know the Earth has a molten core, right?
Okay.
And we discovered the moon does not have a molten core. In fact, we know from its mass, from it going around the Earth, that its density is much lower than the average density of the Earth because it's also missing, it doesn't have a big nickel iron core in it like the Earth does.
Okay.
Oh yeah, I also have a question.
Yeah. Go ahead. You forgot it. That's okay.
You can always say over another time.
Yeah, but here's another question that I just thought of.
Yeah.
Do you think Mars could have water sometime?
Well, there's good. So here's what I'll ask you in response. So, why would the Earth get all the water and the other terrestrial planets get none of it? There's no reason why, right? We should expect anything that happened to the Earth, unless there was something special that caused it, would have happened to all the planets. Now, Mars and Venus, though, processes might have happened to either trap the water or then to lose the water. In the case of Mars, as it cooled down, it obviously had plate tectonics and volcanoes in the past. Because when we look at Mars, there are volcanoes on the surface of Mars. There are volcanoes. They're the biggest volcanoes in the solar system on the surface of Mars. Okay. There's the volcano Olympus Mons, which actually, its crater, its caldera at the top is bigger than the state of Illinois. Okay, so big volcanoes. So clearly Mars used to have internal heat. It used to have a liquid interior. It used to have plate tectonics, like the plate shifting around, like on the surface of the Earth. While that happened, it would have had a working what we call carbon cycle and maintained a thicker atmosphere. And with a thicker atmosphere, it could have had water on the surface. But as it cooled down and the carbon cycle shut down, that led to the atmosphere thinning out and the water probably evaporating and being lost to space, or freezing and getting locked in different places on or under the surface.
Okay, but also...
So 1 billion years ago, Mars might have had as much water as Earth did.
Yeah. But...
And we can see on the surface actually evidence of water flowing at one time on the surface. Yeah. Yeah.
So how does our atmosphere how was our atmosphere created?
So mostly by gases outgassing from volcanoes. So as the Earth cooled, volcanism actually produced a lot of the gas that we have in our atmosphere. Now, that would have been mostly carbon dioxide. But, so the other major thing that changes our atmosphere is the life. So the blue-green algae in the ocean, they're responsible for making about 99% of the oxygen in our atmosphere. And actually, oxygen is a gas that wouldn't exist very long in an atmosphere unless you keep producing it, because it's reactive. You know, it will burn things, or it'll cause things to brown or rust or other things. The oxygen will combine with other things and get locked up. That's what happened. If there was any oxygen on Mars, that's where it is. That's why its surface is rust colored. The oxygen got trapped in the iron in the soil, making it that red color. So, but on Earth, the volcanoes keep adding to the atmosphere over time. The blue-green algae in the ocean keep processing it. And so, you know, together, all of that creates the atmosphere we have. And well, now human beings put stuff in the atmosphere too. And that's also,
pollution.
well, that's true too. I mean, that's something that that's all stuff we do. Yeah.
Yeah, so I'm also guessing about like 0.001% of humans put like carbon dioxide in the air, then turns into like the atmosphere. That's what I'm guessing. I'm gonna.
Well, see, the deal right now with humans is that we're taking the carbon dioxide that was trapped in rocks in the crust, in coal and other things, and we're taking it out of the rocks and putting it back into the atmosphere faster than the volcanoes would do it. And so that's what's led to a little bit of an imbalance in our atmosphere. As a result of the Industrial Revolution and burning coal and gas and things like that.
Okay. I'm out of here. Everybody stays for the questions.
I'm glad. Good questions. I hope to see you again soon. Thank you.
Thank you so much.
Thank you.
Thank
You're
you.
welcome. Any luck? No.
Trying my best.
You'll give Janie a look when you get a chance. I don't think she's had a chance to take a look tonight. How are we on time right now? Okay, we're about 9:45. Okay.
Yeah.
So I've got through the line, I take it, since nobody's clamoring at the door.
Yeah, it's almost here.
Okay. Whew. I think Jennifer said something about she hit 69 people at one point.
No, like she told like she hit 109 around 9:30.
Okay, but did she, as people left, did she let people in?
Yeah.
She also counted 6 deer and 3 raccoons. Okay. Oh wow. Jennifer says we had over 109 people at 9:30.
Yeah.
Woo! Over twice as many as last time. We love our Moon Star party.
Yeah.
Switch the view so we can see what's going on out on the deck right now. Oh yeah, look! The deck shows there is no line right now. And we can see the moon has moved across the sky. Okay, it looks like we don't have many people left, do we?
Yeah.
Well, that's good. Whew.
Is
We
there
had a lot of people.
Is there any other star like we can focus on now?
Not tonight, no. And the moon is so bright that I don't want to move to anything else. I'm sorry, not tonight.
Yeah.
Not tonight. Actually, I'm gonna, 1 second. Oh, that's the wrong way. There. So anybody there watching the stream, the reason why the moon's a little darker now is because it's being blocked a little by the dome. But I'm not gonna, we're almost at the end, and so I'm not gonna move things to correct that right now. And how did things go at the 3-inch telescope? People enjoy that?
Yeah, yeah.
That's a different one. That's a lot. It can be fun to do.
Yes.
Yeah.
People were like coming and then again seeing like when they were going.
Yeah. No, that's good. That's a good one to start and end with because you
Yeah.
get to see the whole moon, right?
Yeah.
Send me any good ones you get. And actually, you might try the 6-inch on the end because the 6-inch telescope, you see the whole moon all at once, and that might work better for trying to take a picture. Yeah.
Thank you, Doctor.
Yeah. Thank you for coming out. Don't worry, I saved the pieces. Well, we're winding down here at Star Party right now. We're going to start putting things away soon. And so I think we're going to sign off. I want to thank everybody that was here tonight. Hope you enjoyed hearing what was going on in the dome and watching the moon. We hope to see you in person at one of these things, and we'll do this live stream again sometime soon now that I figured out how to do it a little better. Okay? So thank you everybody for coming out, and we will see you guys hopefully sometime in the future.